Bar freshness, I be on my Ecxel. Claim they hard, they be Microsoft Ecxel.
Okay, so I was in the lab the other day with Haley, and we started talking about correlation matrices. And she asked, what are those? And so I said, so I described them on the board, but I think it's a good thing to see. And I just want to let you know, these are pain to do in Excel, but you should know what they are. So we are going to do them. And you're going to probably learn a bunch along the way. And this is not going to be perfect. You really need to do this like in Python or R. This is where you do correlation matrices. But I'm going to show you, and you'll see how it goes. So here, we're looking at some soil lead data. So we have lead, arsenic, calcium, rubidium, potassium. And you want to know what's correlated to what. So you want to know lead arsenic, lead calcium, lead rubidium, lead potassium. But then you're going to also want to know arsenic lead, which we just already did, lead arsenic. But then you go arsenic calcium, arsenic rubidium, arsenic potassium, and so on. So we're going to try to do that today. So for example, you might initially make a graph of lead versus arsenic. So insert a graph. Ooh, but that didn't work. Why didn't that work? Because in some of our data, you'll see this happens often. It has an NA. As soon as there's an NA, it plots funny in Excel if there's ever any text. So I'm going to replace that NA. I go here, replace. So I'm going to find NA, replace with nothing, replace all, replace 38. Close. Now let's see if it'll now plot lead and arsenic. So we're going to go lead, arsenic, insert, scatter, scatter. Right, and then you can see they look decently correlated. I'm not gonna play with that graph because that's not what we're trying to do. We're trying to make a correlation matrix. So look, do something like this lead. I'm gonna copy these, put them up here, but then I'm gonna want to make a matrix of them versus themselves. So I'm actually gonna do a paste special. Paste special. I'll show you, and you can transpose, right? And then look, it flips it. So now we're going to do lead versus lead, lead, arsenic, lead, calcium, lead, rubidium, lead, potassium. Right, and so if you do this, you can do, I'm going to start with lead, arsenic. So we're going to do equals correl to find out if they are correlated. So you're going to do lead, all the leads. Let's scroll down. Right, this is going to give us our R value. Right, we want to know the R value because I know if it's positively or negatively correlated. Right, you come back up, close parentheses, and ooh, it did not. There it goes, 0.67. But look, I'm going to need dollar signs on my lead, so I'm going to put dollar signs in front of the C's. So this way, look, I can drag it both ways. So if you go this way, go this way. Now I have it, and look, and you expect lead to be 1, right? Because it's correlating with itself. You have lead arsenic, lead calcium, lead rubidium, lead potassium. So we're going to make this whole matrix. And you actually only need a top or bottom half, but we're going to make the whole thing. So now we're going to try to do this other one, lead arsenic. So if we copy this, here's for dragging down won't work, right? So it'll mess things up. But if you go in here and copy, then hit X, then click on another one, then click and then hit paste, it puts the same in, right? And so we don't want CC now, we want arsenic lead. So we're going to want arsenic to be our fixed one. So we're going to make that D as our fixed one, D as our fixed one, right? Hit OK, and then it should look good. And if we scroll it across, we should get arsenic, arsenic 1. Yep, arsenic, arsenic's 1. And look, arsenic lead is the same as lead arsenic, right? It doesn't matter. The correlation is the same, right? So you can see it's a symmetrical matrix. Okay, so now we're going to try to do this again. I'm going to copy this, copy it down, copy it down, copy it down, click in, copy. And this one's supposed to be calcium lead. So I think for this one, now that we see it, I can actually just click the blue one and drag it across. Now it's the E's. Right, and look, 0.201, it's the same. We are symmetric. Right, and so these are symmetric. And look, we have a negative correlation, which can happen, right? They're negatively correlated. So as calcium goes up, rubidium goes down. Okay, I'm going to try this again. I'm going to click in, X out so I can do it, click in, put it so it has it. But now we want rubidium lead. So I'm going to slide this across. Slide this across. Good, it's working. We should get a 1 where we have it. Yep. And we're starting to see symmetrical. Then our last one's going to do potassium. So copy, X, click, click in, paste, click on. We want potassium to be our blue fixed one. We're going to slide across, slide across. Okay, and then you can see that we have a symmetrical matrix. I'm going to make this a little bit narrower so that it looks a little bit sharper. Right, it's a little bit easier to see. But the next question is, these are just our R values. They show you the correlation, but are they significant? So to do that, we need to go back. There's 2 ways you could do it. We could check every one of these in, we could do our regression analysis that gives the p-value. That would be a pain because look, we have 25 of these. So that would not work. But we can figure out what are the significant values. So if we know, so we're going to want a p-value. We're going to do less than 0.05 and less than 0.01, right? P for less than. We're going to need to know what R you need to get that. At what R does it become critical? For that, we're going to need our counts. I'll make a count over here, count. I'm going to do this. We'll get a count on all of them. Count. I'm going to make all these a little bit smaller so we can see them. So you go equals count. Right, and the reason we're counting is that there might be data missing here. So here's all of our leads. I'll do leads. I'll scroll down. So leads. I'm going to close that. The computer's acting funny. Close it. There we go. There's a 463 lead measurement to scroll that across. 425. So we have 425 arsenic. So we'll just use, I don't know. I guess we're going to try 463 because there's arsenic is the only one that doesn't have it, but we'll try it. And so then to get the critical values, I'm going to go back to our stats. We're going to do p-value calculator. We've used this before. Quick p-value calculator. P-value from Pearson R. So we know, so what we're going to do is we know our n is 463. And so what we can do is if we put in like a 0.2, we can calculate what we get. So 0.2 would give you, it's a really tiny p-value for that. So that means you don't need that high in R to get something significant. So let's try 0.1. So 0.1 gives you a 0.03. So let's try, I'm going to try 0.09. So 0.09 gives you 0.0. So if your R score is above 0.09, we know we're significant at p less than 0.05 value. So I'm going to go do that. So that's going to be 0.09. We're going to go back and do it again. Now we want to know when you go 0.1. So we go 0.1, when point significant at 0.03. So let's go a little bit higher, 0.11. Significant at 0.0. Let's try 0.012. 0.012, look, it just makes it. So if you have an R score of 0.12, we know we're significant at the 0.01 value. So I'm going to go put that in here, 0.12. But here's the thing that happens. What happens if I put a negative in front of here? Negative 0.12. It doesn't change anything. So it doesn't matter if it's a positive or negative correlation. It's still significant, right? Because this is an R value. When you square it, everything becomes positive, going from 0 to 1. But for that's R squared. But for R, it doesn't matter. So we actually have it like this. If I go back to Excel, you have R, you're going to have minus 0.09, minus 0.09, try again, and minus 0.12. So what we want to do to make life easier, we want to color these red when it's less than 0.01, and probably a yellow when it's less than 0.05. So now you can quickly see what's correlated. This will really help you look at your data. That's why we call it correlation matrix. So let's see if we can do this. You can do conditional formatting. This is a little bit tricky, and I always forget how to do it. So you go conditional formatting, new rules. So there's a highlight cells rules, right? So you can do when it is greater than. This is going to take, so format only cells that contain a cell value greater than 0.12. I just clicked on that, see? And make it red. So let's see if this works. And then you can see, Look, all the ones that were greater than 0.12 are now red. And these are our significant correlations. But that's not everything we want. So we want to do, right? We want to do if it's 0.05, and then if there's nothing, and also look at missed the negatives. So we know that doesn't work. So let's see if we can highlight these. We can do more complicated conditional formatting. So what you actually do is you can click Manage Rules. This gets a little bit tricky, so I breathe deeply. I'm going to add a rule. Right? Nope, we want classic. Format, no, only cells that contain a cell value. Watch this. So you want to do a cell value that's greater than 0.09, and then we're going to make this yellow. So I'm going to hit OK. And then what you want to do is if you have to then adjust these. You have to adjust these. So what you're going to do is, because it says stop if true, so it's like if it's greater than that, stop, then check that and make it yellow. Let's see if this works. Oh, so that did not work. Because look, this 0.009. Oh yeah, it did work. Because look, 0.09. Nope. See, look, I think it worked. Because we have none that are yellow. 0.009, right? So I think we have none that are borderline, right? This 0.09. So we could do greater than or equal to. Let's see if we can go conditional formatting, manage rules. I'm going to click on this. Can we edit rule? I'm going to click on the yellow, edit rule is greater than or equal to. Let's see if that does it. Let's see if it does it. No. So I'm going to try this. There you go. So it has to be somehow there's a. This is actually less than 0.09. Watch, I'll show you. I'm going to make them all 3 decimals. 0.090. See, it's not going to work. So it's actually less than 0.09. I bet it's 0.09. Like 0.08 something something something. So it does not work. But however, what we do have to fix, I'm going to actually make these 2 decimals so it's easier to see. Now we have to get these negative ones. So let's go highlight it. I'm going to now go back to my conditional formatting, manage rules. And so what we're going to do is we're going to say, look, we're going to add a new rule. We're going to go back to classic, cells that contain cell value. We actually want less than. Look, if it's less than 0.12, let's click there, make it red. But also we're going to want to stop if that's true also. Okay, let's see if this works. I'm going to click it. Look, right, and it made those red. And then the last thing you can do, right, then we did not, there's no need to make this. We know none of these are true, but let's just make it for completion. So let's do conditional formatting, manage rules, new rule. Click on the last one. New rule. I'm going to do classic. Cells that contain cell value less than. Click in here. Minus 0.09. I'm going to then make that yellow. Hit OK. And then we're going to see if I get to move this one down. We should see if this works. Right, and it should work. So now we should have, we're not going to have any yellow, but otherwise it should be good. Right, and then we can have it. And so there it is. So now you can, if you look at your data closely, you can start to see what's correlated. So you can see, right, some people don't like showing the whole matrix because it does get, and you don't need the one. So I'm going to, I don't know what I want to do. Maybe I'll let's try deleting the ones. We could delete the ones. Like that. That looks pretty good. And so now you can quickly see what's correlated. You can see lead sort of is correlated with everything. It's highly correlated with arsenic. Interesting, rubidium is correlated, and it's negatively correlated with the calcium, and high correlated with the cat. So rubidium and potassium come together. So this is a nice way to quickly look at your data. What I would probably do now to make it look better for this here, I'm going to make this fill, I'm going to make this sort of a red. I had trouble getting this red, just so you know. What you can do is if you click more colors, we can go and try to find that red. See where I think that red is. No, maybe I'm gonna go there. So that's the red, and we don't have any yellows, but you could then click. You could have yellows if it goes yellow, right? And so then you can nicely see. They can nicely, quickly see your correlations. What I'd probably do is if you're gonna let's see if we put the borders on it. Yeah, now that looks pretty sharp. See, now you have a nice correlation matrix with your R values, and you can quickly see what's correlated at what level. As I said, there's programs in R and Python that do this, but this is nice. You can look at correlations within Excel. Good luck.